Hello students, welcome to Abdemi's YouTube platform. Today we are considering a problem from oscillation. So see the statement of the problem. A spherical ball of radius r is floating in a liquid with half of its volume submerged in the liquid. Now the ball is displaced vertically by small distance inside the liquid. Find the frequency of oscillation of the ball. See what is the situation. So there is a ball, there is a ball, half of which is submerged inside a liquid. Radius of the ball is r and rho s density of sphere and rho l is the density of liquid. Okay, now since when it is floating in equilibrium position, half of its volume is submerged inside the liquid. Therefore, the volume of displaced liquid is 2/3 pi r cube, because it is stated that half of the volume is submerged in the liquid and volume of the sphere is obviously 4/3 pi r cube. Now by Archimedes principle, when it is floating, weight of displaced liquid, which is 2/3 pi r cube rho l into g, is equal to weight of the sphere, which is 4/3 pi r cube rho s into g, and therefore I can write rho l is equal to twice rho s. Rho l is density of the liquid is twice that of sphere. Now it is submerged, now it is displaced by a small depressed, the ball is displaced vertically by small distance inside the liquid. So what happens? The situation becomes like this. So the height above, if it is displaced in this direction, then if it is displaced by delta, then the height above liquid level will be r minus delta. Is it not? And the center of the sphere has displaced by amount delta. So this distance is r. Since it is displaced by delta, the center has gone down by a distance delta and the height above liquid level is r minus delta. Now in this situation, what will happen? This weight of the displaced liquid will be more than weight of the sphere, because this equation will not be satisfied in this case, because the volume below the liquid level will be more than half of the volume of the sphere, and as a result the weight of displaced liquid, which is upthrust, that will be more than weight of the sphere, which is in the downward direction, and as a result there will be a net unbalanced force. Net unbalanced force in the upward direction, displacement in downward direction, and net upward force will be in the upward direction, and as a result there will be simple harmonic motion when delta is very small. Now we have to find the frequency of oscillation of the sphere. So before we proceed to solve the exact problem, let us try to calculate what is the volume of the sphere above the liquid level. I call this level as the liquid level. Alright, this is the liquid level, above which, below which some part is submerged and above which it is there. So what is the volume of the sphere above the liquid level, whose height is r minus delta? That we have to calculate. So for that we will work out some formula, and that we will use in further solving the problem. So come to this figure. So what is this figure? We are just interested to find. So consider this as x-axis, this is the sphere, this as y-axis, and this line which is perpendicular to the plane of the board. Plane of the board is xy plane, and this is plane perpendicular to the plane of the board is xz plane, and this is xz axis which is perpendicular to both x and y and perpendicular to the plane of the board. Now consider this is xz plane, and this distance is obviously r, because r is the radius of the sphere. Now consider a plane parallel to xz plane, and this height you consider r minus h. If this is r minus h, this is h, so this distance total is obviously r. Now take a plane y equal to r minus h, and through that plane y equal to r minus h is a plane like this, plane of the palm. And if you cut the sphere, then what is the volume of the sphere above volume of the sphere above y equal to r minus h plane? And if I call this v dashed, then we can show this comes out to be pi h square by 3r minus h. Alright, now we will try to prove this formula. How it can be derived, we will check. Okay, this is the formula that is useful to solve the problem that we are considering. Now for that, what we do, so this is the v dash is the part of the volume of this sphere which is lying above y equal to r minus h plane. This is the sphere, center is at 0, 0, 0 point. Radius of the sphere is r. Total volume of the sphere is v equal to 4/3 pi r cube, and the volume of the sphere that is lying above y equal to r minus h plane is actually v dash equal to pi h square by 3 into 3r minus h. Now I am interested to find the volume v dash. So for that, what we do, I take a cross section of the sphere which is at a height y from xz plane. So this distance is y, this distance. So if this distance is y, if I take a cross section through of the sphere at this plane, then what is the radius of this circle? This circle's radius, if I call it r, then r, y and capital R, they are related by Pythagoras theorem. So y square plus r square is equal to r square. So r square is r square minus y square. Alright. Now, what is the area of the circular patch, this particular patch? I think you are able to visualize. So I am considering this particular circle. So its area is pi r square, which is pi r square minus y square. Okay. So, if I take a small thickness dy like this, if I separately draw this, it is dy. dy is very small. So, volume of the elementary cylinder is how much? If I call it dV dash, is actually pi r square dy. So, dy is actually very small quantity. So, the entire volume of the sphere, part of the sphere lying above r minus y equal to r minus h plane is actually v dash, which is nothing but integral y equal to y value is r minus h here just at this plane, and when I am reaching the top of the sphere, y value is r. So, if I integrate y equal to r minus h to r, pi r square dy gives the volume of the part of the sphere lying above y equal to r minus h plane, which is v dash. So, it is how much? It is r minus h to r pi r square minus y square dy. Okay, so it is how much? Pi r square r minus h minus pi by 3 y cube I think this is clear. So, v dash is how much? It is pi r square r minus h, so it is pi r square h minus pi by 3, this is r cube minus r minus h whole cube. So, it is how much? It is pi r square h minus pi by 3 r cube minus r cube plus 3 r square h. Because it is minus 3 r square h, there is a minus sign, it becomes 3 r square h. Then minus plus 3 r square r h square, and there is a minus sign, so 3 r h square minus h cube becomes plus h cube. Is it okay? So, it becomes this and this pi by 3 r square h, and there is 3 over there. So, I get actually pi r square h minus pi r square h plus pi r h square minus pi h cube by 3. So, these two cancel. So, I get pi r h square minus pi h cube by 3. So if so v dash is pi r h square minus pi h cube by 3. So it is, if I take pi h cube by 3, if I take common, then it is 3r so what happens, this thing pi r h square pi r h square. So what is happening, just let me cross check it once again. It is pi r square and then pi y cube by 3 r minus r to r minus h. So it is pi r square h minus pi by 3 r cube minus r minus h whole cube. Pi r square h minus pi by 3 r cube minus r cube plus 3 r square h minus 3 r h square minus h cube plus h cube. So what happens, pi r square h minus pi r square h plus pi r h square minus pi h cube by 3. So it is pi r h square minus pi h cube by 3. So it should be have wrongly written pi r h square minus pi h cube by 3. So if I just be careful, pi h square by 3 3r minus h. So volume v dash above y equal to r minus h plane is v dash equal to pi h square by 3r minus h. So it's a geometrical consideration. There is a sphere having radius r. Now consider the center is at 0, 0, 0 point. XZ plane is this plane. Then take a cross section of take a cut of the sphere above y equal to r minus h plane. Then above y equal to r minus h plane, what is the volume of the sphere? That we have calculated by constructing a small circular patch at a height y from xz plane. So this distance is actually r square, if I call small r square equal to r square minus y square. So pi r square is pi r square minus y square. Now if I take a small thickness dy and if we construct a small cylinder like this cylinder, if you consider, then volume of the small cylinder will be pi r square dy. Now if we integrate this quantity for y equal to r minus h to r, then I get the entire volume v dash. So this integral, if we carry out, we get v dash to be this much, pi h square by 3r minus h. So this formula we will use pi h square 3r minus h by 3 to calculate, to solve the problem. Pi h square 3r minus h by 3. So just we have calculated, we will recall this formula. we'll remember this formula. Okay, now what happens? Now when it is displaced by an amount delta, so this is again, you consider this is x, y, z axis, this is 0, 0, 0 point, center is at 0, 0, 0 point. Now if it is displaced vertically by a distance delta, then center, this is the level, xz plane is the level of the liquid. So this is the level of the liquid and this is the liquid. And we have already found rho L equal to twice rho S. That we have already found. Alright. Now, when it is displaced by vertically by a distance delta, then the center shifts by delta amount over there. So the center's coordinate becomes 0. This is x, y, z. So center's coordinates become, and this distance becomes delta, and this distance, that means above the water level, how much height is remaining? H is r minus delta. Alright, so if I consider the volume of the sphere below the liquid level is xz plane that we have discussed. So below the xz plane, how much is the volume of the liquid? If I call it V dash, and above the xz plane, how much is the volume of the sphere? If I call it V, if I call V double dash as the volume of the sphere below the xz plane, and V dash is the volume of the sphere above the xz plane, then V dash is actually nothing but pi h square by 3r minus h, that we have calculated. So h is actually r minus delta. So pi r minus delta whole square by 3r minus r plus delta. So it is how much? Pi r minus delta whole square by 2r plus delta. Alright, so it is pi by 3 r square minus 2r delta plus delta square into 2r plus delta. So it is pi by 3 2r cube minus 4r square delta. We should be very careful about calculations, plus 2r delta square plus r square delta minus 2r delta square plus delta cube. So it is how much? Pi by 3 2r cube, and this is minus 4r square delta and r square delta, it gives negative 3r square delta. So these two quantities are considered, and these two quantities, they cancel each other, plus delta cube. Okay. So it is 2/3 pi r cube minus pi r square delta plus pi delta cube by 3. 2/3 pi r cube minus pi r square delta plus pi delta cube by 3. So this is the volume above the water liquid level. Then what is the volume below the liquid level? Is actually V minus V dash, which is 4/3 pi r cube minus 2/3 pi r cube plus pi r square delta minus pi delta cube by 3. So it is how much? It is 2/3 pi r cube plus pi r square delta minus pi delta cube by 3. Okay. This is pi r square delta. It is not. This is pi r square delta. This is pi r square delta minus pi delta cube by 3. So this is V dash, V double dash. So V double dash we have found V double dash 2/3 pi r cube plus pi r square delta minus pi delta cube by 3. Okay, now let us apply Archimedes principle. So what we will do, what is the net unbalanced upward force? So it is to calculate that. So what is the buoyant force? Buoyant force is the weight of the displaced liquid. So net unbalanced upward force is weight of the displaced liquid minus weight of the ball, weight of the sphere, you can say. So when the sphere is displaced by delta amount, delta, this distance is delta. When it is displaced by delta amount vertically downward, then V double dust volume of the sphere is below the liquid level, which is x-z plane, and V double dust we have calculated, and therefore the buoyant force is weight of the displaced liquid, which is nothing but, if I call net unbalanced upward force, this is actually how much? It becomes rho L, weight of the displaced liquid is rho L multiplied by V double dash into G, and weight of the sphere is rho S V G. V is 4/3 pi r cube. It's not difficult problem, it's very simple now onwards. So it is rho L G. Rho L actually is 2 rho S. So I can write it is 2 rho S G V double dash minus rho S G V. So it is how much? 2 rho S G. V double dash we have already found, it is like this. 2/3 pi r cube plus pi r square delta minus pi delta cube by 3 minus rho s g 4/3 pi r cube. So what I get, it is 4/3 pi r cube rho s g minus plus 2 rho s g pi r square delta 2 rho s g pi r square delta minus 2/3 rho s g pi delta cube 2/3 rho s g pi delta cube minus 4/3 pi r cube rho s g. All right. So these two quantities, they cancel each other. So I am left with 2 rho s g pi r square delta minus 2/3 rho s g pi delta cube. Okay. So if I now, this is the net upward force. So what is the net upward acceleration? Upward acceleration, it is in the upward direction. So it is 2 rho s g pi r square delta. So I can write this as actually Fu by mass of the sphere. Fu by mass of the sphere. Now let us calculate Fu by mass of the sphere. So this is Fu that we have understood. Now let us remove this part. So AU, upward acceleration, is actually 2 rho s g pi r square delta minus 2/3 rho s g pi delta cube divided by, what is the mass of the sphere? It is 4/3 pi r cube rho s. So it is how much? So if I calculate, so it is 6 by 4 g delta by r. First term gives this thing 6, 3 to 2 6, rho s and rho s, they cancel each other. So 6g pi also cancel from numerator and denominator. So 6g r square and r cube, so it is delta by r. And from this what I get, it is half. Rho s has cancelled, pi has cancelled. So it is g, half g delta by r whole cube. Okay, so this acceleration AU, upward acceleration, is this much. But delta is very small compared to the radius of the circle. So delta by r is very much less than 1. So delta by r whole cube is a delta by r is a fraction, and delta by r whole cube I can neglect. It is approaching 0. When delta is very small, then delta by r is much less than 1, which is a fraction, and if you take a cube of this, this quantity becomes almost 0. So I ignored this part. So it is giving displaced vertically by small distance. So under this condition, when the displacement is very small, then acceleration upward is actually 6 by 4 means 3 by 2. 3g delta by 2r. Okay, now see, AU is proportional to delta, and delta displacement is downward. When the displacement is downward, acceleration produced on the ball is in the upward direction. So I can write AU is equal to minus omega squared delta, which is equation of a SHL, where omega square is 3g by 2r. Okay, so since we have arrived at this equation, AU equal to minus omega square delta, where omega square is 3g by 2r. So this is, the ball will execute a simple harmonic motion, and this is possible. It's a pure simple harmonic motion is possible only when delta is much less than r. So when the ball is displaced vertically by small distance, then the motion becomes simple harmonic motion, and omega square becomes 3g by 2r. Therefore omega, you know, it is 2 pi frequency of oscillation. So frequency of oscillation, so omega becomes how much? Root over 3g by 2r. So frequency of oscillation becomes 1 by 2 pi root over 3g by 2r. So 1 by 2 pi root over 3g by 2r, it is the frequency of oscillation, and this happens only when delta is very small compared to radius of the sphere, and under this condition it executes a simple harmonic motion, and the frequency of oscillation is f equal to 1 by 2 pi root over 3g by 2r. So this is the problem. So we have arrived at the frequency of oscillation. So conceptually it is a very simple problem. When in equilibrium, half of the sphere is submerged below the liquid level, and from which we calculated the density of liquid rho L is related to density of sphere by this relationship. Now when it is displaced vertically by a small distance delta, then above the liquid level, what is the volume that we could calculate, and this volume is this much. If this height is h, then the formula for volume is actually pi h square by 3 cr minus h, and we have shown how you can derive this particular formula. Now when this is the situation, it is displaced by delta, then the volume below the liquid level, that is xz plane, that we could calculate, and since it is not balanced, there is a net unbalanced force, and from which we could calculate what is the net unbalanced acceleration. Net unbalanced force is this much, and from that we could calculate the net unbalanced acceleration in the upward direction by this formula, Fu by ms, force by mass. Mass is the mass of the sphere, and from that mass of the sphere is this much. So net unbalanced force by mass of the sphere, if we calculate, we get this expression, and in this expression there is a delta by r whole cube term. When delta by r is much less than 1, then we neglect delta by r whole cube term. So I get this expression, acceleration is proportional to delta, and they are in opposite direction, and therefore the sphere executes a simple harmonic motion, and from which we could calculate the expression for omega or omega square, which is 3g by 2r. Omega is square root of 3g by 2r, from which the frequency of simple harmonic oscillation is 1 by 2 pi root over 3g by 12. It is a simple problem. Only trick is that you have to know the volume of the sphere when it is disturbed by delta amount, which is lying above the liquid level. That we have shown how to calculate. So I think you have understood the steps. You should be very particular about calculations. And with this, I conclude this problem, this session. Thank you very much. If you have any doubt, please revert back to us. Thank you.